life on Earth. So it's called the fateful encounter hypothesis. And if that's true, then it's just a bit of luck, and it happened once, right? And that's why we're here.
Now, when
blind luck.
Consider, like, how many billion Earth-like planets did you say exist just in our solar system alone?
In the galaxy, 20 billion, something like that. It's 1 in 10 stars.
So the odds of complex life out of our incredibly fortunate situation, but the odds of that occurring on any of these billions of other planets that exist?
We don't know, but let's say the Earth is, let's say it was on the fortunate side. So we're talking about, give or take, 4 billion years, right, from the origin of life to now, and we have a civilization now, and we've had it. Our species has been around, what, 250,000 years or something? So it's just now, basically. So let's say 4 billion is on the fortunate side. Let's say that it was double that, or triple that on the average. Suddenly, that's the age of the universe, right? And that's a third of the age of the universe it took. So how many of those worlds have been stable for 3 or 4 billion years? That's quite a tall order, actually. It looks like our solar system might be quite unusual in that respect, because the planets got to remain stable in a stable orbit. The stars got to remain stable,
at
least in our solar system. Large moon stabilizes. Jupiter plays a big role.
Takes the asteroids. Sucks them in.
So, and that, there's a theory called the grand tack theory, which is, so it's very hard to explain the evolution of our solar system. So when you do computer models of solar systems, you don't tend to get 4 rocky planets too close to the sun and 4 big gas giants further out. And one of the current best theories, and I say this because it shows you how lucky we might be, is that Jupiter, they tend to form these big gas giants and migrate inwards towards the star. So in almost all the computer simulations, just because you've got this big gas giant orbiting in all the dust around the star, they tend to drop inwards. And it looks like Jupiter did that. So it looks like it formed and came in almost to where Mars orbits today, and cleared out the region around Mars, actually, which is maybe the reason Mars is so small compared to the other, to Venus and Earth. But then Saturn was coming in as well. And in the computer models, the interaction between Jupiter and Saturn stops Jupiter coming in before it gets to the Earth. And they both get dragged out again. And so to where they are today.
Oh, wow.
And so that seems to be, it's one of the best theories for the evolution of our solar system. So what are the chances? The chances of that are so minuscule, tiny. So that's the thing, I think, about these rocky planets. In order to get a civilization on them, I guess you need quite unusual solar systems. And that would be a guess. And you need quite unusual stability on the planet for billions of years. And that's why I think we might be quite lucky.
And how does Bode's law work? Bode's law is a method of detecting, if you look at the mass of a planet, you can accurately detect how much mass and the size of a neighboring planet.
I think, wasn't it just the positions of the orbits, I think.
Right, where it is. Yeah.
And it's one thing that is true about our solar system is that if you get the computer simulations, you can't put more planets in. So if you try and put more planets in, it becomes unstable very quickly.
So the mass of, like, if you measure Mars, you can accurately depict where the next planet close to it would be?
It was. I mean, it was. That's what was done. Was it 17th century or something? I can't remember. It was long. Yeah, and it was just one of those things where you notice a pattern.
Right. They were just trying to figure out what the planets were.
Yeah, so it's just a pattern, which is, there's nothing to that really. Other than to say that most simulations of the solar system, if you put other planets in, they tend to get thrown out by gravitational interactions. So there is a sense in which our solar system has got as much stuff in it as it could have. So the planets are nicely spaced. And you're right, given the mass of them, that depends on how close another planet can be before the interaction goes wrong and it gets thrown out into the intergalactic space or something, because planets do that. We know that planets get thrown out of solar systems by gravitational interactions. So, it points to the fact that solar systems are not stable over long periods of time. They're not like clockwork things. They're not like Newtonian clockwork and it just goes on forever. They're not like that. They evolve, and planets can shift orbits and change. And we know, if you look at the surface of the moon, for example, it's covered in craters. And that was caused, they all seem to hit about the same time. And it's about 3.8 billion years ago or so. And that's called the late heavy bombardment. So we know that if you look at cratering rates on Mars and on the moon, it all seemed to happen in this, not all, but a big peak around that time. And that seems to be correlated with Neptune moving outwards in the solar system and into the Kuiper Belt, basically, or towards the Kuiper Belt, and causing all sorts of havoc, and everything comes into the inner solar system. So those things happen. But it didn't happen when life was established on the Earth.
So it's all extremely old stuff that these shifting took. But how long has the solar system been in this particularly stable situation that's in now?
It's since about 3.8 billion years ago. So if it had been unstable at any point since then we likely wouldn't be here.
Right. Do you think that it's possible? Do you ever entertain the idea that it's possible that we are the only intelligent life in the known universe?
I tend to restrict myself to the galaxy.
Right.
So I do think it's possible that at the moment there's one civilization in the Milky Way.
Wow.
And that's us. And I think that's important, actually. And it goes back to what I was saying at the start about the astronomy and cosmology being part of the framework within which you have to think. If you're looking for meaning, or you're looking for how we should behave even politically, that has a bearing to me. I mean, imagine that we're the only place where there is intelligence in this galaxy. And how should we behave?
Right.
Should we actually, notwithstanding the fact that we're tiny and fragile things and insignificant physically, should we consider ourselves extremely valuable in that respect? Because there's nowhere else where, I would go as far as to say there would be nowhere else where meaning exists in the Milky Way.
Meaning.
Because meaning is one of those things that scientists don't talk about very much. Although Richard Feynman, one of my great heroes, did talk about it. There's a quote where he says, "What is the meaning of it all?"